Hey, special scientists, it's Miss Liz. I am coming to you guys live from my own kitchen, and we are going to have a very special science program today. In today's science experiment, we are going to learn about density, and using everyday objects that you guys can find in your own house, we are going to see if they sink or if they float. All right, so the first thing that we're going to learn is some science terms for today. Every good scientist does their research before they start an experiment, so you know exactly why we're doing what we're doing. The first word we're going to talk about is one that I said a few seconds ago, and that is the word density. I know that sounds big, that sounds a little scary, but we're going to break it down a little bit. Density is just a word that's used to describe how much space an object takes up in relation to how much matter that object takes up. So it's its weight, it's its volume, and it's how many things are made out of it. I know that sounds a little confusing, but that's okay. I have a demonstration for you. So if you guys notice, I have two cups in my hand. They are two identical cups. One's filled with pasta and one's filled with pennies. If you guys look at the pasta cup, you'll notice there's lots of room for air. They're kind of loose in there. There's a lot of space. You could fit more. It has less density than something like this cup of pennies, where there's not a lot of light, there's not a lot of air, they're kind of really stacked in there, it's heavier, so that's what density is. It's how much space, it's how much space it takes up and how much matter is in there. So one's heavier or lighter than the other. All right, in addition to density, our experiment is also going to be testing buoyancy. This is a word you guys may have heard before if you've ever heard of a buoy, which is that thing out in the ocean if you've ever been out there that like goes in the waves. It's usually like a mile marker or something like that. What buoyancy means is it's the force that makes an object sink or float in the water. So if you think of a boat, or if you like a boat floating on the water, or you think of like an ice cube in your glass, it bounces around, it doesn't sink to the bottom, and that is because a buoyant force is pushing it up and making sure that it floats on top of the surface. If a buoyant force is too weak and gravity pulls it down, that's what makes something sink. So that is what buoyancy is. All right, also our last two terms of the day are sink and float, if we don't know what those mean. If something sinks, that means it gets pulled down to the bottom. Think of like if you throw a rock in water, or if you've ever tried to jump in a pool and hold your breath and you try to sink to the bottom. And then the other word is float, where something floats to the top. So if you've ever played with bath toys like a rubber ducky, or you've thrown pool noodle in the pool, or have gone on a boogie board in the ocean, you'll notice that it sits on top of the water. That means it's floating. So now that we've got some of those science terms out of the way, I think it's time for our experiment. So the first step that every scientist has to take is to make sure that we have all the items that we need for this experiment. You never start an experiment without all of your stuff in front of you, because if you start doing something and say it's like a chemistry project and you start like getting a mess everywhere, the last thing you want to do is stop what you're doing, clean up your space, get the thing that you forgot, and come back to it. So as long as you make a checklist beforehand and you guys make sure that you have everything in front of you, you're totally good to go, and the science experiment will be smooth, easy, and breezy. So if you guys are doing this experiment along with us at home and you got the supply list, you guys are going to check your own supplies. If you're just joining us and you want to just see what we're doing, see what this is all about, and try it again later on your own, that's totally fine. I am so glad to have an extra pair of eyes making sure that I have everything I need. So what we're going to do is we're going to go through our checklist, and then we're going to start our experiment. So the first thing that we need are two pieces of paper. You're going to make sure you have them, hold them up, check them out. Doesn't matter if they're lined, blanked, construction paper, colored paper, scrap paper, just two pieces of paper that you could write on. Does not matter what they look like for today's experiment. All right, the second thing that you need is a pen. I know I'm holding a marker, but you guys should have a pen or a pencil. This is just so you guys can see what I'm writing easier on the screen later on. But don't use Sharpie in your kitchens. Your parents might not like that so much. All right, the third thing we need is a cotton ball or a cotton swab. If you guys don't have any of those, you can use a Q-tip. Whatever you have around your house is totally cool. We also need a paper towel. Doesn't matter how big it is, how small it is, if it's a piece of paper towel, if it's a whole paper towel, whatever you got is good to go. You guys are going to grab a fork or a spoon. Doesn't matter the size, doesn't matter which one it is. If you guys see, I love this one because it says my name on it. So it's super special. So this is what we're going to use today. We also are going to take a sponge. Again, doesn't matter the size of the sponge, just as long as you got one. We need a coin. I have a penny, but if you have a nickel, a dime, a quarter, $50, whatever else you got in your house, throw it on in there, it's gonna work. We need a piece of tinfoil. If you guys have guessed the theme already of today, doesn't matter how big, how small, what it looks like, just as long as it's kind of flat like this is what we need. All right, lastly, we're going to need a bucket of water. This is my bucket, I have a nice big bowl. Kids, if you're trying this at home, make sure that your adult helps you carry this water. The last thing you want to do is spill it all over everywhere, because then you're gonna have to start from scratch and delay the experiment even more. So you're gonna put that on a nice flat surface in front of you, which I'm gonna move the camera down in a few minutes to show you what it looks like. And lastly, because we're playing with water, and sometimes scientists get messy, and it's okay, that's why they work in a lab and they have lab coats on. You just want to make sure that you guys have a towel to wipe up any water that you may spill during this experiment. All right, so if you guys have all of that stuff, if everything on your list is checked off, that means it's time to get sciencing. You ready? All right, so the first thing you guys are going to want to do is take one of those pieces of paper, just one, and put it on the ground in front of you. All right, the next thing you're going to do is take your marker, and we are going to create a scientific findings chart. This is because, like every good scientist, we don't just do these experiments for the fun of it, even though they are super fun, but we also do it because we want to collect data and see what we can learn at the end. So what you guys are going to start doing with me is you're going to take your pen and you're going to draw 2 lines vertically down your paper, just like that. All right, and then when you're done with those 2 lines, you guys are gonna draw 9 lines, 9, horizontal across the paper like this. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So your paper should look like a nice graph. And because this is our own scientific finding chart, do not worry about your lines being perfect. They do not have to be straight. Your boxes don't have to be even. This is just some kitchen science, so we're doing it for fun. It doesn't have to be as technical as like a real scientist would be in the lab. They're super precise and super clean, but as you guys can see, mine is a little, crooked, but it's okay. It will still give us the same results at the end. All right, once you guys have that, you guys are gonna use this first graph of 3 across, and we are going to write the word object. In the second box will be what I think. And the third will be what it did. So it should look like that. I'm gonna sit down, I'm gonna get ready for this experiment. Now that we have our graph all ready, we're gonna leave it to the side of us that we write with. So if we're right-handed, we're gonna put it on our right side, which is what I'm doing. If we're left-handed, we're gonna keep it on our left side, because as we do this experiment, we're gonna record everything that we do. All right, so the first thing is to make sure our bowl is right in front of us of water, and we're gonna test our first object. So what I want you guys to find for me is that coin that you have. All right, so what we're gonna do is we're gonna write in our object line coin so that we know what we're throwing in the water, just like that. Because if we just start throwing stuff in water and saying, yes, sinks, yes, floats, when we go back to check our data, we might not remember what we threw in first. If you're like me, I have a very bad memory. So I like to make sure that everything is written and everything is keeping track of. All right, now that you've written coin in there, you're gonna write in that second column what you think it will do. Does it look like it's gonna sink, or does it look like it's gonna float? And you're gonna write sink or float in the column that says what I think. So I think it is gonna sink. All right, lastly, you can push your paper and your pen to the side, just ever so slightly, so you don't get any water on it. We don't want to ruin our data. And the next thing you're going to do is you're going to take that coin and you're going to drop it in the water and see what happens. Now, if you guys can see on my screen, if you guys are just following along with me, you'll notice that that coin is all the way in that water. He sunk to the bottom. If you guys are doing it at home, I'm hoping that you saw the same results. If you didn't, please let me know. I want to know exactly what coin you're using, because I've never seen a coin float before. So now that you've looked at it, you've seen it, you looked at how fast it sunk, we are going to write what it did. So what it did was, it was a sink, right to the bottom. All right, so now if you guys want to get a little wet, because it's more fun, you guys can go into your experiment and take out your item. If you want to leave it in there, that's totally cool. That's why we have our towel. We can wipe it down and wipe off our hands before we start the next one. Put that coin to the side. We've already tested it. If you guys really like the way it looked or the noise it made or the splash it made, feel free to throw it in again later. If you want to keep throwing it in and not throw another thing in this water, that's totally cool. The great thing about science is it's whatever experiment you want to do, and whatever piques your curiosity and what you want to learn about. I, however, want to learn about this paper towel. So in my object line, I'm going to write paper towel. Just like that. All right, and then I'm going to guess that this paper towel is going to float. It feels kind of light, feels kind of airy. Not really much to it. I don't think it's that dense. So I do think it's going to be buoyant, and I do think it's going to sit on top of the water. So I'm going to record that in my what I think section, and I wrote float. So you guys are going to take a guess, figure it out based on what you think this paper towel feels like, and write down your observation of it. Once you have a guess, it is that time again for us to drop it in the water. All right, so if you guys are looking at home, you guys can see that my paper towel started on the top, but it's doing something very cool. It's actually floating down to the bottom. The reason for that is because as the paper towel absorbs the water, it acquires more mass, making it more dense than when it was paper, and it's sinking to the bottom. So if you actually guessed that this paper towel would sink, you are correct. And what that water is doing is making it, it's weighing it down, it's adding more to its surface, and it's creating a very slow sink, but it is still sinking. All right, we're gonna take that one out. All right, the next thing we're gonna try is our spoon. If you guys are using a fork, grab your fork. If you're using a big spoon, use a big spoon. If you're using a teaspoon, use a teaspoon. Whatever utensil you guys want to throw in the water. Like I said, I just like this one because it had my name on it. So I wanted to throw this one in water. So what we're going to do is we're going to write that in our object line. So I'm going to write spoon. You guys are going to write whatever it is that you're using. And then I'm going to guess that this guy is going to sink, like hardcore sink. He is super heavy. He feels really dense. I don't see any air like floating through him. There's no like pockets and holes. So I think he's going right to the bottom as soon as I drop him. If you guys feel differently, that's totally cool. It is your guess. So write down whatever it is you think is going to happen. Time for our favorite part. We are, I'm going to move my paper over because I already got water on it. And we are going to drop him. That one was fun. I really like the splash that he made, and I got it everywhere. But that's okay because we're in the science lab, in the kitchen science lab, really. So if we make a mess, it's just water, no big deal. That's why we got our towel to clean it up. All right, so now that we saw that that guy went straight to the bottom, we can write sink and what it did. Next up, we are going to take our cotton swab, cotton ball, Q-tip, anything you guys got lying around the house will totally work. I'm using a cotton pad. So that is what I'm going to write in my object line right here. If you guys are using something else, just record what you're using. And if you're following along with me, then you're using the same thing I'm using. All right, and I think, so based on what the paper towel did, right? The paper towel kind of felt similar. They're both made out of like really light, airy materials. I'm gonna guess that this guy's gonna do what the paper towel did, which is absorb water. So he's gonna take on more mass and he's gonna sink to the bottom. And this is the really cool thing about science, because you use the knowledge that you gain from other experiments to guess what you think something will react that's maybe similar in size or state or feeling. And that's why we collect this data, to see what happens, to maybe see if it's right, if there's a pattern, if every object that feels like this does the same thing, or if that just because it feels the same doesn't mean it's going to react the same. So that's something you use later on once you collect all your data. So now what we're going to do is drop it in the water. And this guy is a surprise. Oh, nope, I lied, he's not a surprise. He is sinking to the bottom. He was doing a graceful little water dance all the way down, so he's sunk. He did exactly what I think he would do based on the paper towel results, and he went to the bottom. If you used a cotton ball, you may notice that it takes a little bit longer. That's because the cotton ball is more concentrated. It's usually like this kind of shape. So it has a lot more layers for that water to penetrate before it can acquire the mass that it needs to sink. But if you leave it in there long enough, I promise you it will go to the bottom. Next, we're gonna take our piece of tinfoil, and no matter how big your tinfoil is, I want you guys to rip it apart. Rip it like kind of down the middle as much as possible, like this, so it's in two pieces, because we're gonna give this one a twofold, just because I'm curious to see what happens. So we're gonna make sure to chart this in our object line. So we're gonna put tinfoil right there. And then do you think it's gonna sink or float? So I'm guessing, because he's a metal, like the penny was, or whatever coin you used, that penny sunk. So maybe this tinfoil will sink, because they're both different metals. So that's my guess. If you guys feel differently, if it's because it feels lighter like the paper towel, maybe it's not, doesn't have as much mass, it doesn't have as much matter, you think it'll float, definitely guess that one. It is totally up to you what you want to do. And what we're going to do is we're going to keep one of these flat like this, and we're going to take the other one and crumple it in a ball. I want to see if this makes any difference, because what we did was we just made the surface size of this super small, and this one is super long. So what we're going to do is we're going to take the long one, and we're going to drop it in. Huh, look at that. This guy is floating. That is totally not what I thought was going to happen. And just for the sake of an experiment, we're going to take that crumpled ball and see if that changes anything. Because now we made him smaller, we made him more dense. Maybe this will push out some of his surface space. Nope. Both floating like a boat. All right, so now that we see that those guys are floating in the water, we're going to record that in our what it did column, which is down here. Sorry, I'm getting to the bottom of the page now. So I have two more items that we're going to throw in this water. I hope you guys are still with me. I hope you're still throwing stuff in. I hope this is still exciting like it is to me. I love a good splash. I love a good experiment. Our second to last thing we're going to drop in there is a toothpick. It's this guy. If you guys don't have a toothpick, you can use a bamboo skewer. You can use, if you get a lot of Italian ices, those like roundy things that you like use to scoop them up. If you ate any popsicles lately, you can use a popsicle stick. If you have a big craft selection, you can use a craft stick. Anything that's got like this wood kind of texture and feel to it. So in my kitchen, we had toothpicks. That's what we're using. All right, and he's feeling pretty light. I don't think he's feeling that dense. It's not like weighing my hand down. I think he's gonna float. So record those out, right what you think it will do. And in 3, 2, 1. He is floating! Yay! We were right. I'm not gonna lie, I wasn't sure about that one. So I'm glad I guessed right, because that just makes me happy. That being said, if you guess wrong, that is totally cool. Don't worry about it. This is what science is all about. Science is about testing stuff out, guessing what you think will happen, and recording what actually happens. There's no right or wrong in science. Science is all about the experimentation process. collecting data and then what you formulate after it. So don't feel like you have to get all these right. That's why we guess and then we record the results. All right, lastly, we have a kitchen sponge. This is gonna be our final thing that we're throwing in water. If you really love this experiment and your grown-up says it's okay, feel free to throw more things in your bucket of water, whatever you guys can find in the kitchen. If you guys were with us earlier, you noticed I had pasta. I could throw this in if I wanted. It's all up to you. It's all your science game. So whatever makes you happy and whatever your grown-up says you could do, feel free and go for it. All right, so we're gonna record our last one down here. And I think this guy's gonna float in this state. If you're using a wetter sponge, feel that he's a little bit denser and make your guess based on that. And then we're gonna drop it in the water. Ready, set, drop. Ooh, he did float. Up, 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 up. I think he's going down. All right, he's still floating. He's like middle. Like he's like half on top, half on bottom. So I'm gonna write float and then take him out before he could sink. If you guys are using a sponge that's a little bit more wet, it has a little bit more to it, you will notice that he's gonna sink because what happens is like the paper towel and like the cotton pad is a sponge. If you notice, if you really look at it, it's got holes, which means it's porous, and those pores get filled with water and it absorbs the water. It makes it heavier, it makes it more dense, it gives it more matter, and that's what causes it to sink because the gravitational force is pulling it down and it's less buoyant. So those are some science terms for you that we learned today. All right, so now what we're gonna do at the end, we're going to move our bowl of water to the side, because if you're like me and you're accident prone, you will spill the bowl of water and that will not be fun. Your grown-up may not like that. And what we're gonna do is we're gonna track our scientific findings. So we're gonna count how many we thought were gonna sink and write it in this thing right here. So out of the 1, 2, 3, 4, 5, 6, 7 items that we tested, so we're gonna write 7 underneath the object. How many did we think were gonna sink? 1, 2, 3, 4. 4 we're gonna sink. And 1, 2, 3 we're gonna float. We're gonna write that in our lines down here. So we thought 4, I thought 4 were gonna sink and 3 were gonna float. If your numbers are different, you guys are gonna write what you think it is. And then after what you thought was gonna happen, we're gonna do it on the other side of what it did, and we're gonna count up the sink and the float. So I had 1, 2, 3, 4. 4 sink. And 1, 2, 3 floated. My science is a little messy right now. That's okay. I made a mistake. If you make a mistake, that's okay. So what this is this is our raw data. And every good scientist, when they're done, if they want to keep these results, they move it over and make it neater, make it cleaner. They usually put it into a computer. For today's, it was just fun. We don't have to save this data for anything. If you plan on continuing this experiment, I would definitely save this because over time you can formulate an idea. Because if you see that a paper towel sinks, a piece of paper sinks, a newspaper sinks, and like a coloring page that you did sinks, you may be able to guess that based on all of those items that paper, no matter what it's like, no matter what something's made out of, if it's made out of paper, it's probably gonna sink. So that's how you formulate ideas, predictions, that kind of stuff based on the stuff that you tally. However, if you're like me, this was just for fun. I like getting science to throw it out like that. So now, all right, so now that our science experiment is done, good job, you guys made it through. I hope you had fun. The biggest thing we're gonna do right now is we're going to clean up our science station. Every good scientist, even though we work in a messy lab and we might have a messy space, they do not leave that area messy when they're done, because when the next person comes in, they need a clean slate just like we had. Thank you guys so much for joining me. I hope you had fun. I hope we learned some new things today. I hope maybe we learned some new words. If anything, we got to throw stuff in water, so that's always a good time. And I will see you guys again soon. Bye.